Hello everyone and welcome to the last tutorial of week 4. So let's get started. So our sixth question is, let x be a random variable having PDF as fx equals to 1 upon 2 lambda e to the power minus lambda x. So here mod lambda x. So we already know that mod x is generally equals to minus x if we have x less than 0, right? And will equals to x when x is greater than 0. Right, so according to this mod x we have now the PDF. So now the PDF will be fx of x equals to 1 upon 2 lambda e to the power minus lambda x. So minus into minus of x will equals to lambda of x when x is less than 0, and will be equals to 1 upon 2 lambda e to the power minus lambda x when x is greater than 0, right, depending upon the value of x. So now we have to calculate the CDF of x. So CDF of x can be calculated directly by integrating the fx on the limit x, right? So now, so for the first case, when x is less than 0, what we have to do? We have to integrate from minus infinity to x. Okay, if x is less than 0, so that x mod of x can be replaced by minus of x, right? And then we can directly write upon 1 upon 2 minus infinity to x, where x is less than 0, so we have replaced mod of x with minus of x, so we are having lambda e to the power by lambda x, so that can be replaced directly. And now we know the integration of e to the power lambda x. So e to the power lambda x is what? Integration of e to the power lambda x dx would be e to the power lambda x upon lambda with the limit whatever we have to put, minus infinity to x. And now we'll put the limit. So we first put the x here and then minus infinity. So e to the power minus infinity is 0. So we'll be having that lambda will get cancelled here, and e to the power lambda 1 upon 2 will come here, and e to the power x minus e to the power minus lambda, e to the power minus lambda is 0. Sorry, e to the power minus infinity is 0. So we have got this one for x less than 0. Now we'll move for the x greater than 0. For x greater than 0, mod of x will get replaced with x, right? So now we have to do the integration from minus infinity to x. So till minus infinity till 0, that mod of x will be replaced with minus x, okay? And from 0 to x, that mod x will be replaced with x. So I guess you are understanding why we have written in this two part, because we are calculating CDF. So CDF of x will be the probability, the summation of all the probability till this x value, right? And x is greater than 0, so we are doing the summation for all the minus infinity to infinity 0, and then from 0 to x, where x is positive here, okay? So what we have done now, so this mod of x will get replaced with minus of x, and then we'll do the summation for this minus infinity to 0. So that will be equals to 1 upon 2. So that can be represented here. See, 1 upon 2 lambda e to the power. Now we are having lambda of x, right? Dx. And that we have to do the summation from minus infinity to 0. So that will be equals to 1 upon 2 lambda e to the power lambda x upon lambda. So lambda will get cancelled, minus infinity to 0. So lambda will get cancelled. 1 upon 2 we'll put e to the power 0 is 1, minus e to the power minus infinity is 0, right? So we'll be having 1 upon 2. So we have written here 1 upon 2 directly, and then we are having 1 upon 2 0 to x, where x is greater than 0, so that mod of x will get replaced with positive x. So now we are doing the integration e to the power minus lambda x, and then the minus will come by the integration, and we'll put the limit 0 and x. So we are getting this one. So for x greater than 0, we have this CDF. So this can be represented now. So for x less than 0, we got e to the power lambda x upon 2, and for x greater than equals to 0, we are having 1 minus e to the power minus lambda x upon 2. That you can see from the options, and you can mark the options. So now we'll move to the next part of this question. So here we have been asked to calculate for e to the power mod x, e to the power I'm telling, exponential expectation of mod x and variance of mod x, okay? And lambda has been given as 1. Okay, this is for the hint simply. if we are having that integration from minus infinity to 0 of x e to power x, you can directly write it as -1. You can calculate also, but we have written it as a form of hint, so that if somebody is having problem in integration, you can write it directly. Okay, so now if lambda equals to 1, so will that PDF will get changed to this one, because we were having lambda e to power lambda x, so lambda is equals to 1 now, and here also it was lambda, so this would be the simplified version of the PDF. Okay, if we have to calculate for y is equal to lambda x, y is equal to mod x, so again for x greater than 0 we can directly write it as x, and for x less than 0 we can write it as minus of x. So how generally we calculate the expectation? So expectation can be calculated, that expectation of generally this function into that PDF, and we have to do the integration from minus infinity to infinity, right? So what we can do, so for x greater than 0, x less than 0, we can directly write this x as minus of x, right? And then fx we can write. Similarly for x greater than 0, we can directly write x as mod x as x here, right? And then the PDF of x for x greater than 0, and then we'll integrate. So -1 upon 2 will integrate from minus infinity to infinity this x of e to power x, right? And we already know the integration of this minus infinity to 0 x e to the power x. So we have got the value as -1, so we will write directly -1 here. Okay, so -1 upon 2 into -1 will get 1 upon 2, right? And similarly for 1 upon 2, 0 to infinity x e to the power x, we already have the summation as 1. Okay, so we'll write directly as 1. So 1 upon 2 plus 1 upon 2 is equals to 1. Now we have to calculate the variance. So for variance of x, how generally we calculate the variance? So variance can be calculated as expectation of y square minus expectation of y ka whole square. Okay, so what we have to get, this value we already have 1, so this we have to calculate. So how we'll calculate this e to exponential of y square? So simply we have to take y square everywhere in spite of x, in spite of y. So what is that y? Mod of x. So mod of x can be represented mod of x square, because we have to calculate the expectation of y square. So we'll write mod of x square into PDF of that x. Okay, so what is that? Now we are having mod of x square. So mod of x square will be simply x square for all the values for x greater than 0 or x less than 0. So everywhere it will be x square only. Why is that? Because if mod of x is simply what? Mod of x is simply minus of x for x less than 0. So if we'll square this value, so the minus of x will get squared on, so we'll be having x square for all the values for x less than 0 or x greater than 0. Okay, so now that x square got changed, now we'll be having 1 upon 2, and we have to integrate from minus infinity to 0 and then 0 to infinity. Okay, so this value we already have the value as 2. This for this also we already have the value as 2, so we'll write 1 upon 2 into 2 plus 1 upon 2 into 2. So this value has been written here, so you don't have to integrate it, so you can just get it from the hint. So now we are having 2 as a expectation of y square, that you can write it like directly 2 minus and 1 ka whole square. So we are having the value as 1. Excuse me, 1. So we have got the value as variance of y also 1 and expectation of y also 1. So now we'll move to the next last question of this tutorial. So now we are having the expectation, now we are having a random variable that has been defined as uniform from 0 to 2. That is simply from 0 to 2 it has been defined. Its value would be 1 upon 2, right? So the support of x is what? 0 to 2, right? And y has been defined as exponential of x. So the support of y is what? 0 to e to the power 2, right? So now we are having everything, the support of y and support of x. Now we can directly calculate the CDF of y. So what has been asked? So PDF of y has been asked. Okay, so first thing we'll check whether for the whether that function y, that is e to the power x, is monotonic in support of x or not. So exponential of x, what we can directly write it as, so e to the power x we can draw, and we can see whether this function from 0 to 2 it is monotonic or not. So if we'll put the value of e to the power 0, that is 1, and e is square, so at 0 it is 1, and at 2 it is e square, so this is e square, right? So this function, we can see this is totally monotonic between from 0 to 2, that is the support of x. So we can use our formula, because this is a monotonic, this is differentiable at all the point, and this is monotonically increasing, so we can use our basic formula that generally we use. Okay, so now we can write it directly. So for to use the formula, what we have to get it, we should be having f of x of what, g inverse of y, right? That is in the denominator, and in the in the numerator, and in the denominator we have to get z inverse of y. Okay, so this is simply the f of y that we have to calculate. For that, what we have to get, the g inverse of y, and then we have to differentiate the function, that is e to the power x. Okay, so f of x is simply what, 1 upon 2, first from 0 to 2. So the numerator would be 1 upon 2. So we don't have to care about the numerator. Now we have to care about the denominator. For denominator, what we have to get? We have to get the g inverse of y. Okay. For g inverse, get g inverse of y, what is that value? So what is the function? Y is equal to e to the power x. So we'll take log of y is what? X. So that g inverse of y is what? Log of x. Log of y, right? So this we have got now. Now we have to get the g dash of x. So g dash of g x we already have. This is so y dash. What is the value of y dash? Would be exponential of x, right? So now we can put directly all the values in this formula. So this is our formula. Okay. So we can directly put it here. See, we already have that g dash of x, and g dash of x, what in the denominator, what we have to put, g dash of g inverse of x, y. So wherever we are having x, so we can directly put that inverse. So exponential of log y is what? Y, right? This is the basic properties of logarithm. Okay, so now we are having everything. Now we are having the denominator part also, and the numerator part also. So what is the numerator part? The numerator part is 1 upon 2, and the denominator part is what? Y. So now we are having the PDF of y as 1 upon 2y, right? That you can get it from here also. After putting all this value would be 1 upon 2, and this value would be y. So you can directly get 1 upon 2y for the support of y. Okay, sorry, the support of y would be from e to the power 0 to e to the power square, so that is 1 upon e square. Okay, right? So now from 1 to, for the support of y, from 1 to e square, we'll be having the PDF as 1 upon 2y, and then 0 otherwise. So thank you everyone for attending this session. Bye.